LLMs Terminology. We have covered a quick intro for LLMs in AI Session 1. Its link is in description. In a line, LLMs are large language models, that is foundation models trained on a very large input vectors primarily targeted towards generative AI. In this session, we'll cover the popular terms you have been noticing when getting involved with LLMs or other ML models in general. Let's start with some basic terms and proceed to level up. First, tokens. Tokens are basic processable units of data that can be processed in models. For text, it would be a word, subwords, characters can be tokens. Second, vectors. Vectors are a way to represent tokens in a numerical representations. So it can be used as input for mathematical algorithms used to train ML models. Third, embeddings. Embeddings are high-dimensional vectors that capture semantic relation among all tokens of vectors. Semantic relation primarily reflects the closeness among tokens, the structure, the grammar. So converting several text into embeddings help in LP tasks. Embeddings are foundation to LLMs. Fourth, vector databases. Vector databases are required for LLMs as when using millions of embeddings to efficiently identify closely related embeddings. These are very helpful. These abstract out storage, indexing, and fast similarity retrieval for embeddings as a focused software implementation. Some examples are Chroma, VV8, Pinecone, Postgres with pgvector. Even Redis has support for this. Fifth, transformer. It's a deep learning architecture that learns context and meaning by tracking relationship in sequential data. It utilizes the self-supervised training in an encoder-decoder configuration. The transformer model is a neural network that is particularly effective for NLP tasks. Other than LLMs, it has also been successfully used in models like Whisper, which does automatic speech recognition, thus transcription, with image transformers to generate images, as with diffusion transformer in stable diffusion. Sixth, parameters. Weights and coefficients that ML algorithms gets from training data are model parameters. Parameters gets adjusted during training phase. These are factors that model learns from training data, then utilizes to make predictions. More the parameters trained on more data, generally better the model's ability to generate required output. Generally, the sizes of parameter count of 8 billion, 70 billion, 400 billion, like huge counts, are shown with LLMs to showcase their quality to refer these models parameters that have gone through training data to understand the data. Then hyperparameters are essentially components of a model that are dependent on ML algorithm in the learning phase, but not changed by training data and don't become part of resulting model. These control model shape or behavior. One of such hyperparameters is LLM temperature that regulates randomness of AI's response. The lower the value, the more deterministic the response would be. The higher the value, the more creative the response would be. Then hallucination. In AI, a hallucination is a confident response by an AI that does not seem to be justified by its training data. It happens primarily when an answer wasn't available in training data, but model erroneously finds similar data to generate. It can also happen if training data somehow had unverified, untrue text in it. GPT or generative pre-trained models. So GPT-3, GPT-4 are LLMs developed by OpenAI. These are kind of NLP models trained to map and generate human language like text. These are pre-trained on massive general datasets available, learning structure, grammar, and context of languages. Trained on transform model allows handling data sequence efficiently. Then LLAMA. LLAMA is a series of LLMs, LLAMA 1, LLAMA 2, LLAMA 3, trained by Meta AI, available publicly for local usage and research. It can perform text-based tasks as text generation, paraphrasing, summarization, etc. LLAMA 3 is trained in data from 30 plus languages, thus supporting multilingual tasks as well. Fine-tuning allows LLMs to be trained to focus specialization on specific capabilities and or context domains. Capabilities like translation, completion, query response, etc. Context domains would be like code LLAMA, that is fine-tuned model on LLAMA 2. So code LLMs are possible using this as well. Now RAG or Retrieval Augmented Generation is an application architecture designed to power LLMs to answer questions about data unavailable in the training set. Primarily helpful to allow LLMs answer using latest information without constant retraining. It bridges gap in LLMs and external knowledge sources. Even an LLM like LLAMA, trained on public data, can be capable of answering questions about your personal finances. External knowledge is stored in vector databases as embeddings for LLMs to grasp. It's not a perfect alternative to avoid retraining though. Prompt engineering involves designing prompts for models to generate high quality output. Prompts are input patterns used to guide LLM's behavior for output to be relevant to a specificity. Appropriate keywords and phrases, specifying the desired output structure, and optimizing for performance and efficiency are key. Zero-shot prompting is to prompt for a task without specific training of context-specific tasks. Here, LLMs rely on its generalized understanding of tasks to give a response. One-shot prompting, here like zero-shot model, isn't aware of the context beforehand, but is provided with one labeled example before attempting the task. Few-shot prompting, also in-context learning. Here like one-shot prompting, when attempting a task with having access to more than one guided examples, the task can be attempted. Chain of thought prompting enables complex reasoning by providing intermediary reasoning steps to a final task. This can be combined with few-shot prompting to get better results on reason-based context-specific problems. Context window is the number of tokens that are considered when predicting the next token. Modality is a high-level data category for model. For example, text, images, video, audio. LLMs deal with anything text. Multimodal AI is a model that can process information from multiple modals as text, image, audio, and video. Use cases are like providing an input of a tourist spot as a photo and asking to generate a list of good spots that can be visited nearby. So these are the key terms that we have explored in this session. More later.